Kia ora, Year 9. This video is for people who are working a little bit ahead in class, and I'm going to look at two skills in here. The first one is how to find the equation of a line when we're given a point on the line and the gradient of the line, but no graph. And the second one is when we're given the 2 points on the line and one of them is the y-intercept. And there's a worksheet that slowly ramps up the difficulty level that I'm going to give you out in class and chuck onto Google Classroom later on tonight. Okay, so the first three all have the same pattern. I'm going to give you the gradient of the line and I'm going to tell you where it goes through, 1 point. And we have to figure out the equation of the line. So we know now that one way we can always write the equation of a straight line is in this form here. Y is equal to mx plus c, right? C is the y-intercept. And that's what we get when x equals 0. Y will work out to be c. For example, if the line is y equals 2x plus 5, we know straight away now that that line is going to go through the point 0, 5. Then the other thing we know about it is that it's going to have a gradient, a steepness number of 2. So for every increase in 1 of x, the line, the y value is going to change by 2. So x is going to go up by 1. That means here that y is going to go up by 2. And if you're watching this video, I want you to be pretty confident with those basic ideas. So what do we know here? Well, the gradient of the line is 2. And that means that we know that my line will have the form y equals 2x plus a number, and we'll call that number c. If we look at it in GeoGebra, all we've got so far is that the line goes through this point 5,9. Here it is. So that's the point at 5,9. Now that actually is a blobby point, guys, before you start asking. It's just that I forgot to fix up the scale. So looking at it by eye, we should be able to get a feel for where that line's going to go. It's got a gradient of 2, so the line is going to look kind of like this, and we can't really tell from looking where it's going to go, but let's just try and do it this way just one time. So we could go back 1, that gets me back to 4, and down 2. And then we could trace it out, right? What we're going to do is we're going to do that using algebra so that we're not screwing up that terrible ruler that now won't move. The ruler won't go. I'm going to do it without the ruler. Now, here we go. The ruler's working now. So we're going to join up point A and that point that I just drew in, and we're going to see where they join up. And it looks like it's going to go through somewhere around -1. And that's actually what the answer is going to be. But let's go back and do that using our brains instead of a ruler. Rulers are good though. We like rulers. Always bring your ruler to maths. Okay, so substituting in this point, we know that that point is on the line. So that means that I can say this: 9 is equal to 2 times 5 plus c, right? Because I know that this point is sitting on my line, and I know that the gradient's 2. So for 9 to be on it, it must all work out. So 9 is equal to 10 plus c, which tells me that c is equal to -1. That gives me the equation of the line is y equals 2x, take away 1, which fits exactly with what we saw. Okay, I want you to pause the video now and try these next two, and I'd like to see some nice clear working in your books, like I've done here, only yours should all be lined up, not all over the page. Right, so if you've had a go at that, we can get on with it now. Remember, you can also use Desmos or GeoGebra to check what you're doing as you work. The gradient is -3, so that means the line has this pattern, -3x plus c. We know that this point is on the line. Substituting in gives me -9 is equal to -3 times 2 plus c. -9 is equal to -6 plus c. So I can add 6 to both sides here, or in this case I can just say, what does c have to be? But this is good practice for when we do some more equations work. So on this side, we're going to add -6, and that gets us to -3. And on this side, we're going to add -6 so that it goes to 0. So we get -3 is equal to c. The equation of the line is -3x, take away 3. And I think I've done that one in GeoGebra as well. Let's see. Maybe not. Oh, yep, there we are. Is that the point 2 -9, or is that the next one? Yep, there it is. Okay, so you can see that line there fits what we've just done, I think. Maybe that's another example. No, that's not the same example, guys, forget it. All right, Too many videos in one day. So the next one is very similar, except the gradient is -1. It goes through 5, 9. So my working is going to look like this. Y is equal to -x plus c. Now I sub in my point. 9 is equal to -5 plus c. C is going to equal 14, right? So I'm adding 5 to both sides of the equation. That gives me my final answer of y equals x plus 14. So that's those three done. Right, now onto these next ones. So a few ways we can think about what's going on here. I've given you 2 points, but one of those points is the y-intercept in each case. So for this first question, find the equation that goes through 0, 1 and 1, 3. So doing some really bad drawing here, we know this point is 0, 1. Now that's more useful than lots of other points because it means my equation will be y equals mx, not plus c, but plus 1, because 0, 1 is on the line. And in this first one, I can see from looking what m is going to be. So m is equal to the change in y from one point to the next over the change in x. The change in y here is from 1 up to 3. So it's 3 take away 1. And the change in x is from 0 up to 1. So it's 1 take away 0. So that gives me 2. That means that the equation of the line is equal to 2x plus 1. So here we had 2 points and we found out the gradient directly, right? We used our definition of gradient, which is the rise, the change in y over the run. And that worked out to be 2, so that was my equation. There's another way that we can do it, which is just a different way to think about the same thing. So we know that 0, 1 is on the curve, and that tells us this, but we also know that 1, 3 is on the curve. So we can do what we did before. We can substitute these values in, and that's going to let me find the value of the gradient. Right, so 3 is equal to m times 1 plus 1. 3 is equal to m plus 1, so m must equal 2. And that means that the equation of the line is y equals 2x plus 1. Both of those methods are really useful ones as you work your way through maths at high school. Then one more for you to try. So pause the video and have a go at this and do your working in your book. Sorry about the piano and singing in the background, but I can't make my family all be quiet when I'm doing vids. So what do we know? Well, y is equal to mx take away 4. And I'm going to do this the second way by substituting the point in. -10 is equal to m times -2 minus 4. I'm going to add 4 on to both sides. I'm going to keep the equation balanced as long as I do the same thing to both sides of it. So -10 plus 4, here's 0, here's -10, plus 4 means I'm going to go to -6 is equal to -2m. Now I'm going to divide both sides by -2, or I'm just going to look at it and see what it's going to be. So m must be equal to 3. So -6 divided by -2 is equal to 3. Y is equal to 3x take away 4. So there you go. That's doing it the substitution way. Finding the gradient directly should give me the same number. So let's do it that way now. M is the change in y over the change in x. So we can go from one to the other. So -10 minus -4. Made these numbers quite hard to keep you guys awake. Divided by -2 minus 0 gives me -6 over -2, which is 3. Okay, so 2 methods for you to do that. So have a go now at the worksheet questions, guys. There are quite a few you can do on there. And then we'll look at how to work with parallel lines later on. Most of you can probably figure out the other pattern types just from these skills here. Thanks for watching.